Welcome to this tutorial video on using audio for VATSIM for vSTARS and vERAM users. vSTARS and vERAM are the primary radar clients for approach, departure, and center positions in the United States division on VATSIM, but they can also be used by any air traffic facility that supports them. If you are looking for VRC or Euroscope help, there are separate videos for those clients. Please check out audio.vatsim.net to find more information on VRC, Euroscope, and Pilot clients. No air traffic control clients will natively be implemented for the launch of audio for VATSIM. However, the developers of these clients have committed to working with the Audio for VATSIM team to solve the issues with Audio for VATSIM that are unique to air traffic controllers and the clients they use, and we hope to have full native implementation soon. During the transition period, all controllers will need to use a small standalone program called Audio for VATSIM to provide air traffic control services on VATSIM. We will cover the installation and use of this program, the changes you need to make to vSTARS and vERAM, and how controlling utilizing Audio for VATSIM is different than what you are used to, including how to manipulate and cross-couple frequencies. First, we need to download the Audio for VATSIM Standalone Client. This can be found at audio.vatsim.net/AFV. Once the download completes, it's a standard installation, and let the program install into the default locations. So this Audio for VATSIM MSI is the program we're going to run to install. Now once it's installed, we're going to run Audio for VATSIM. It's possible if you've been in the beta test, or if the update has changed after you've gotten your link, that you may need to update the Audio for VATSIM client. If this is the case, you will get an automated pop-up, and you'll simply click the update button. The update will download, and once it's downloaded, follow the prompts in order to get updated to Audio for VATSIM. It's possible your antivirus system may also need you to provide an exception. Simply do that. Okay. At its core, Audio for VATSIM is a very simple program, but we have powerful advanced features. To start, we'll configure it by opening our settings window, and we're going to enter in our VATSIM CID and our VATSIM password. We'll select our microphone device. You have a click down for multiples. Your output device, do the same. The output value can remain at -1 or wherever you would like. We'll adjust this later as we want to adjust our value through our headset. And then we come down to the mic volume slider. Now, I'm sure you noticed in the video that this colored bar here keeps moving. This is very important. For best reception on Audio for VATSIM, your voice needs to be peaking within this green bar. If it's down in the blues, as you can see here, I'm too quiet, and in the video you probably have a little bit of problem hearing me. And if it's too loud, it's going to peak in the red, and you're going to be overmodulated. So this mic volume slider bar will adjust your mic volume. So as you see, I moved it to the left, now I'm in the blue. I moved it all the way to the right, and I'm peaking a lot in the red. So we'll adjust, so for the most part, my voice is in the green. Below that, we have a box that says, Disable realistic ATC audio effects, not recommended. And this is truly not recommended. If you check this box, what will happen is you will remove all of the VHF simulation from Audio for VATSIM, resulting in a crystal clear bass codec with no alterations. So Audio for VATSIM in this case would sound like TeamSpeak or Discord. And this is only recommended if you really have a need to have the voice that clear. So for the most part, keep that unchecked. We'll set our push to talk button using this setting here. And then simulator settings as air traffic controllers we can disregard. This is for our X-plane and our FS9, FSX users that are using Swift. So we'll hit apply, hit OK. Now vSTARS and vERAM both function very similarly when it comes to audio for VATSIM. I'll cover the use of both so you can see the similarities and the slight differences, as well as to illustrate a key feature of audio for VATSIM, and that's the ATC transceiver database. We'll talk about that more shortly. To use vSTARS with audio for VATSIM, simply open up vSTARS like you normally do, and allow vSTARS to check if there's any updates. If there are any updates, update vSTARS, and then reopen it after the update. We will select our facility, and we'll connect to the network like we normally do. As you can see now, OK, and A, I am connected to the network, but we're not going to prime our frequency yet. When we go to prime our frequency, we want to check our RTVS and make sure we left-click the prime button so that receive and transmit are both green. The headset loudspeaker buttons here, we do not want to click, we want to leave those blank. Instead, what we're going to do now is go back to audio for VATSIM, and we're going to hit connect. And you can see there's been a couple changes now. I have my position call sign here, Minneapolis H approach. And then the window expanded, and I have my call sign here again, Minneapolis H approach. And I have my frequency I've primed, 135.47, that matches up here. And I have transmit and receive lit green. I am now ready to begin controlling using audio for VATSIM. When it's time for me to transmit, I will simply press my push to talk button, and you will see that my transmit light has lit up to orange, and that means I am now transmitting. Same thing with receiving. When I'm receiving text, my receiving light will light up. Now, if desired, there are some options to minimize the approach or the screen that audio for VATSIM takes up. Your first option is to simply minimize it back to your original. This really is not recommended, as this is just for the pilots, and we really need to see this area. This is our communications panel. So for controllers, we have a couple options. We have the minimized mode by hitting the up arrow here. And we get just this little box that'll show our transmit status and the last received call sign. Even better is to hit the plus sign, and it brings up our communications panel again, and we can use this to manipulate everything that we will need to control on VATSIM. Now, audio for VATSIM is very different from what we're used to, in that voice rooms are no longer a thing. Instead, pilots and controllers just simply transmit on a radio on a frequency. For pilots, this is very simple. The pilots have radio antennas on the aircraft, and since the aircraft is moving, their radio antenna is moving, so they can transmit within the VHF line of sight range that they're within. And that VHF line of sight range is going to increase and decrease based on their altitude. Air traffic controllers don't have it as easy. Air traffic controllers instead rely on ground-based fixed radio towers called transceivers. Now, VATSIM has two sources of setting up these transceiver towers. The first source is controller client, and that's the one we will show now. The second one is the VATSIM database, and we'll talk about that in our discussion on vERAM. Now notice under the disconnect button here, it says transceiver source. Next to that in yellow text, it says controller client. What this means is that audio for VATSIM is using the visibility center in our controller client, and it is placing a transceiver on our visibility center. The radio range of the transceiver on the ground that it's placing corresponds to the type of position that we are working. So in this case, we're working in approach position, which means at sea level, the maximum range of our transceiver is 12 nautical miles. Now, as an aircraft climbs and descends, his reception range is going to increase. So in reality, when we're talking to aircraft at altitude, our transceiver is going to have a range of about 242 miles. Now, audio for VATSIM is smart enough to know what position you're working. So if you're working a tower, it's going to limit that further. If you're working a center position, it'll be more. Now, for most approach, departure tower, ground, and clearance delivery positions, the default range is going to be enough to adequately control almost any airspace with little to no communication issues. There should not be any signal degradation or things of that matter when you're working smaller airspaces. Now, vSTARS only allows you to define one visibility center. So you'll only be able to have one transceiver using the controller client method. Now, if you do find that you're having a hard time hearing pilots or there's signal degradation and you should not be, let's say they're at your major airport, we have the ability to add additional transceivers through the audio for VATSIM Standalone Client by typing the ICAO code for the airport in the additional transceivers window and hitting add. You will see your transceiver count adjust accordingly. Note, you must remove all additional transceivers if you wish to remove one. It is not possible to just remove one. So as you see, my transceiver count here is 1 because I'm using my one transceiver for controller client. Now let's say I have a pilot that is up here at Anoka County and I'm having trouble hearing him. I come to audio for VATSIM into the right box and I would type KANE and hit add. Now that's going to add another transceiver at the Anoka County Airport, and you can see my transceiver count has upgraded to 2 now. And then to get rid of it, simply remove all. If you're temporarily relieving a controller that is below you in the top-down hierarchy in VATSIM, you are able to add that controller's position within the Audio for VATSIM Voice Communications panel. Simply hit the plus button below your position, and then type the controller's position name and hit enter. So let's say I am going to take over Minneapolis Tower. You may be asked to enter a frequency for the position as well in this separate pop-up window. You can do that and hit OK. Now you'll see the position has appeared in the Audio for VATSIM Voice Communications panel. We're simply going to left-click on the Transmit and Receive buttons. And when we do that, we are now able to transmit on the secondary frequency of 126.7 as well as our primary frequency of 135.47. Now, if you're concerned about pilots stepping on each other without knowing it, we can cross-couple those frequencies together in an attempt to cut down on simultaneous transmissions. So right now, pilots that are on the frequency 135.47 will not be able to hear the pilots that are on frequency 126.7. So if a person is calling the tower and a person is calling you on approach at the same time, they could potentially block each other. So to cross-couple the frequencies, we will hit the cross-couple button here to turn it green. Now everybody will be able to hear everybody, similarly to VATSIM's old voice. When that controller returns from his break, you can stop transmitting on his frequency again by left-clicking the Transmit, Receive, and Cross-Couple buttons, or simply hit the red X button to close them all. An important note when you are relieving another controller is to make sure that in addition to adding the position on the voice control panel, you come up and you hit transmit and receive on that same frequency. This way you hear the tower controller's text frequency as well, and you don't miss a text-only pilot. Those are the basics on how to control a vSTARS. We will go ahead and sign off, and we will open up vERAM to have a discussion on how to control with vERAM. And as you can see, I disconnected from vSTARS, and audio for VATSIM automatically disconnected. Now using vERAM follows the same process as vSTARS. We're going to open up the vERAM client. Again, we'll update it if it's necessary. And we're going to connect to the network like we normally do, except we're going to set communication in audio for VATSIM instead of the VC or VSCS panel. So here we go. We're going to connect to the network. And we're going to go to our VSCS panel and get that configured. We're going to prime our frequency like we normally do. We'll do that by clicking on the frequency, clicking the transmitter on, and then in the middle box, we are going to right-click only so that primary is shown in the middle box. Do not left-click in the middle box, as that will turn on your speaker, and we don't want that. So again, left-click on the frequency itself, turn on the transmitter, right-click middle box to turn primary. We're going to connect to VATSIM. As you can see, we are now connected. Here's the key difference for vERAM versus vSTARS, as most center positions are going to be pre-configured to use the VATSIM database. The VATSIM database is maintained by your local facilities engineer to pre-populate your transceivers. Here's an example of Mexico. The small little rings are where the transceivers are and the range at sea level. And then the large rings are at flight level 350, approximating where an aircraft in altitude should be able to hear. So as you can see, we don't need a lot of range on the ground because we do have a lot of range in the air. Now, for larger airspaces, we will need a lot of transceivers to run our airspace. So you can see transceiver source, VATSIM database, and transceiver count is 57. Minneapolis needs 57 transceivers to adequately cover the airspace. If you are curious to where your own transceivers are, or where pilots are in relation to those transceivers, you can check the VATSIM map for that information. Here we see all 57 of Minneapolis' transceivers, and you can notice that these are all at ground level. And you can see there are some areas in my airspace where I have no coverage. This is perfectly normal. In the real world, there are areas where there are radio gaps, and aircraft need to climb higher to be in range of a VHF radio tower. Here we have a pilot in the Denver area, and he is at altitude, flight level, or he is at 6,500 feet and climbing. As you can see, his range ring is quite large, and it will get bigger as he climbs higher, becoming more in range of the various radio towers. You can use this map to judge if an aircraft is in a dead zone. If the aircraft is in a dead zone, he will have to either depart VFR and pick up IFR clearance when he gets higher, or he will have to send you a private message in order to get his IFR clearance. the Audio for VATSIM team is working on a better solution to solve this problem. If you are using a VATSIM database for your transceivers and you notice that you might have a problem with the actual data itself, inform your local facility management. As explained, there will be areas in your airspace at low altitudes where you may not be able to communicate with pilots. This is intentional and it is realistic. Facility engineers will not change configurations simply to have 100% coverage on the ground. Now, if you sight onto a center position and your transceiver source says controller client, that should be a red flag to you. The controller client method is not recommended for the center controllers. If you sign on and see that controller client is your transceiver source, please ensure that you have connected it as the correct call sign as defined by your local procedures. Each facility has defined the transceivers by call sign. Now, if you're unable to get a hold of your facility engineer immediately, you can continue your VATSIM session using controller client, but it's not recommended. You will most likely have gaps, and you will have to add additional transceivers as seen in your vSTARS video. Now, there are multiple ways to cross-couple frequencies. What cross-coupling is tying frequencies together so that controllers can transmit on multiple frequencies, as we saw in the vSTARS example taking over a controller's position. And it's also allowing for pilots to hear across multiple frequencies or hear aircraft that they shouldn't. So the first option for cross-coupling is literally to not cross-couple at all. What this means is audio for VATSIM will work exactly like a VHF radio, and pilots will have to be within range of each other and an ATC transceiver to hear both ATC and each other. For example, if I have a pilot over here and I have a pilot over here, they both may be able to talk to air traffic control, as they will both be in range of an air traffic control transceiver. Let's say the transceiver is over here and then there's one over here. They will, however, not be able to hear each other. So I, as the air traffic controller, might give an instruction to the pilot over here. And this pilot will hear the instruction, but he will not hear the response. To fix that, we use what's called same frequency cross-coupling. And we'll turn on the cross-couple button. And by doing that, pilots' transmissions are now rebroadcast over all transceivers that air traffic control owns. So the pilots will be able to hear all the other pilots, similarly to our old voice system. Single frequency cross-coupling will be the primary method of using audio for VATSIM for center controllers. However, a more advanced ability currently exists and will be further refined by the Audio for VATSIM team, and this is known as simplex and duplex coupling. Simplex coupling allows for the controller to work multiple frequencies using the transceivers that are assigned for each frequency. So in the previous example, I was working Minneapolis Center combined using single frequency coupling. And in that case, every transceiver I had was on the frequency 133.40. And simplex coupling, instead, I'm going to work multiple frequencies, and each set of frequencies is on its own set of transceivers. This is how it works in the real world. And as you can see on the VATSIM map, my transceivers look very similar. The key difference here is Minneapolis 20 Center is on frequency 133.40. And then I have Minneapolis 20 Center again on 124.40. In reality, this is the 4 sector, and this is the 20 sector. So my call sign will show the same, but I have different frequencies for each set of transceivers. This method can cause mass confusion for pilots as they will have no idea what controller to call, what frequency to call, and they will be unable to hear a controller on the wrong frequency. To fix this, we can do what's called duplex coupling, where we hit the cross couple button on everything, and now both pilots and controllers broadcasts are transmitted over all transceivers. So this method will allow for controllers to give frequency changes across their airspace, but it is a little complicated and not necessary for VATSIM purposes. Local facility management and division management will advise you on what methods of cross-coupling you are allowed to use. That covers the basics of vERAM. With both vSTARS and vERAM, your controlling will not change on the radar client itself. You will still use your commands to tag targets and do handoffs and actually work the traffic. The only change is how you actually communicate. The frequency management is a bit advanced, and you have the option to use that if you choose to. However, for most purposes, we will still use single frequency and a push to talk. If you have any questions, check out audio.vatsim.net for the guides and the vatsim.net forums for support. To download the standalone client, you can get it directly from audio.vatsim.net/AFV. We look forward to bringing you the future of VATSIM, and we hope you enjoy our new voice technology.